I'm going to go through the reviews for ICLR 2024. I've never submitted to an AI conference, but I'm just super curious, kind of what are the common types of things people say in the reviews. So I'm going to go through and try and use DocETL to try to find patterns, common weaknesses that many of these papers, these submissions exhibit. So I've kind of scraped all of the reviews and uploaded them as a JSON file. Each object in this JSON has about 100 reviews in it. And it's kind of ridiculously hard for a human to go through and understand all of that, but hopefully with DocETL and LLMs, we can get a sense of this. So the first thing I'm going to do is come up with a pipeline starting with a map type operation that will take each document and kind of extract weaknesses, common weaknesses from each document. Call it extract weaknesses. And a map type operation simply applies a map, applies an LLM call to each document and outputs whatever we want in a certain schema. The prompt, maybe we want something like find common weaknesses in the reviews in the paper reviews event. And then these prompts are Jinja templates. So I can just reference the content key in the input document. And I want the output schema to maybe be simply a list of weaknesses. Um, I'll make it a list of a string. And the important thing to note here is I've configured the pipeline to run on a sample of just 5 documents. So that would be like 500 reviews. Just because I don't really want to go through the whole thing right now. I just want to see what this would look like on a sample. And I've configured it to use GPT-4o Mini. So, okay. So now I'll run this. And when I run the pipeline, I can see basically some progress as we are kind of executing this operation on each of 5 documents. And once this finishes, which might take a little bit of time, we run the operation for every document in parallel. So you can see it's great. It just took 19 seconds. And I can see the output table here. I'm going to close the dataset viewer. I don't need that anymore. And I'll expand these weaknesses here just because I'm kind of curious on what it says. Make this a little bit bigger. And it seems like okay, limited novelty and approach, long-tailed learning. I don't even know what long-tailed learning is, but you know, limited benchmarks and eval metrics, confusing presentation with several acronyms. The first thing that kind of stands out to me is that there's a lot of jargon in here that I don't understand, nor do I really care about, right? I want the high level weaknesses here. I don't want specific references to specific submissions or papers. Um, like I like this proposed method lacks clarity and robustness. This does seem specific to a review though, and not, you know, all of the reviews that could possibly be here in this content. So maybe I'll need to change the prompt a little bit. Um, Make sure the weaknesses are generalizable, but are common across multiple different submissions, and they are not specific. I'll just put this in parentheses. They should not be specific to an yeah, like I don't want to see something like, you know, GKD or long-tailed learning, um, so forth. So maybe I'll start with that and see how this goes. Okay. So this is a little bit better. I don't see anything very obviously pertaining to submission. Poor clarity in presentation, it's unclear writing style, inconsistent notation, lack of detailed explanations. Insufficient experimental validation, thorough literature review, experimental design flaws. Okay. This seems bigger, but now I'm realizing I'd care also about the format of these. And I also want some like specific evidence or specific quotes for each one of these weaknesses. So maybe more concretely, I want the weakness to be short, this description here, but I also want it to be accompanied with specific quotes from the reviews from multiple submissions. So I can change the output schema of this map operation accordingly. So I'll have weaknesses be a list of objects where I'm looking for the weakness short name as well as quotes. And maybe I'll say in here, for each weakness, succinctly describe it and give a list of quotes from the reviews from different submissions that serve as evidence. Okay. Probably honestly make this a little bit bigger, more readable, but let's do that. And this might take a little bit longer because I am asking for more. Finished. All right. Oh, nice, nice, nice. Okay. So clarity of presentation. The notation is not very well defined and inconsistent. Lack of novelty. It seems like some of these also just have only one weakness, which, I mean, maybe that's the case. This one has a lot. Interesting. This bigger. Limited experimentation, weak theoretical analysis, overclaiming. A lot of stuff around evaluation. I wonder if there are more. Let me ask it to kind of find as many weaknesses as it can. Find as many weaknesses, common weaknesses. And honestly, this is getting to be good enough. I'll probably move on to try to canonicalize the weaknesses across multiple documents after this. And we're here. All right. Clarity and presentation issues, failure to compare with recent baselines, insufficient novelty, lack of novelty. These ones only have one. That's odd. Maybe in these cases, there just aren't more. Or we just have too many reviews in that document. But that will nicely motivate our DocETL optimizer later when we get to that. Cool. Okay, honestly, I think this is good enough for me to start moving forward. So the next thing I want to do is kind of resolve these weaknesses across different documents or different LLM calls. So to do that first, note how each one of these weaknesses is actually a list. So what I want to do is flatten out this list so that every row of my table is its own weakness, instead of every row being a list of weaknesses. So I'll do that by adding an unnest operation. Unnest. I'm going to flatten it around weaknesses. This key. Hopefully I spelled it right. And I want to flatten it recursively. Basically, I want weakness short name to end up being a new column in my output. Let me do this. Unnest weaknesses. Cool. And now I'll run this, and it'll leverage the cache from the cached outputs from the first operation. So we don't have to worry about the cost going up. As you can see, the cost didn't change. And now here are the outputs of this operation. So if we scroll down, exactly, I can see kind of weakness short name here, which is awesome. And I can also kind of get a sense for the selectivity, which is basically the ratio of the number of outputs to the number of inputs. So we can expect on average maybe there to be 3x as many weaknesses that arise from the number of documents. And of course, this is such a small sample. I'm sure that'll be different when we run in a larger sample, but it's always good to kind of get that sort of idea. So now what we want to do is kind of group these weakness short names to group these weaknesses together. And you can see things like maybe they're already like insufficient novelty and lack of novelty and technical contribution are kind of the same weakness. So if we were to group by weakness and summarize all the quotes for each weakness, we would want these like novelty related weaknesses to be in the same group. So to do that, I'm going to add something called a resolve operation here. But actually, before I do that, let me save progress. All this does is kind of write the state of our session to local storage. So if I reload the playground, all of this data will come back, which is nice. And then I'll add my resolve operation. Another thing I might want to do in another analysis, kind of side note here, is I might only want to look at the rejections and see what the weaknesses are. But anyways, moving forward, let's see. Resolve. So think of the resolve operation as a entity resolution or canonicalization. So I'm going to call this canonicalized weaknesses. And the resolve operation asks me to define a comparison prompt between each pair of weaknesses, and then a resolution prompt that will be applied to each cluster of weaknesses. And I'll kind of explain that as I do this. So that to compare whether two weaknesses are the same or not, I might say something like, you are comparing two types of weaknesses described in AI paper views. Please determine if these two weakness types are reference should be grouped together as they are essentially the same. And then I might say weakness one can reference also the Ginger template, input one dot, I think it's called weakness short name. Okay, and then weakness two is input two dot weakness short name. Great. And then the resolution prompt. So basically this comparison prompt will run on pairs of weaknesses, and the resolution prompt will be applied to each cluster of weaknesses. where each cluster is determined to be the same semantic weakness, and canonicalize those weaknesses into one weakness short name. So it's going to end up overwriting this weakness short name field. And I might say something like, have the same phrase here. Determine the canonical name for the weakness for the following types. And then I'll kind of want to do a Jinja for loop here, which I never know off the top of my head. So let me Google this. Okay. Let's see. Wait, this. So I'll say for input in inputs, and it needs to end with N4. And we can say weakness input dot short. Oh, sorry, weakness short name. Cool. And I kind of want this. Oh, I'm selecting this. I also want this to be somewhat short. The canonicalized name should be 4 to 5, then words. Yeah. Okay, so if we were to run all pair comparisons on our entire data set, we would have n squared LLM calls, which might not scale. So we can kind of optimize this operation to prune away pairs that are very obviously not going to be weaknesses, based on their embedding, or sorry, that are very obviously not going to be duplicates based on their embedding similarity. And I encourage you to read the documentation to learn more about that. But the way to do that in the interface is to press this optimize button. You can kind of watch it interactively optimize in the console that we've got in the front end. And it is kind of running the pipeline on a fresh sample of document, which it should use the cache here. So I might look into that to see why it's not doing that. And yeah, it cost about $1 to optimize, and we did get a blocking threshold of 0.62, which is awesome. So I'm gonna save this because I don't feel like re-optimizing. And I want to run it just to see what it's gonna give us, honestly. So let's do this. And of course, it's going to read from the cache, which is great. And here is the updated weakness short names. So this is an interesting operation because we can also visualize like the input distribution, so how elements get resolved. So it looks like, we had 4 different short weaknesses that got resolved to lack of novelty. So lack of novelty in technical contribution, insufficient novelty, lack of novelty or incremental contribution, and also lack of novelty here. So that's interesting to me. And what I kind of want to do when looking over this is I'm checking for 2 things broadly. One is for a given group, are all of the bars in there actually part of that group? And then the second thing is, if I look at all the groups here, would I want to cluster any of these groups together? So I'm kind of failure to compare with recent baselines. One might want to put that in insufficient experimental validation and evaluation, but I kind of do see that as 2 different things. Like failure to compare with recent baselines is more specific. Um, Technically, I mean, many things can be clarity and presentation problems, but I do prefer the finer granularity here. Clarity of contribution and methodology maybe could be looped with clarity. Um, Comparative analysis, I don't really know what that one is. If I were to look at the table for comparative analysis, comparisons with recent baseline methods are absent. Ah, so this is a baseline like um, baseline one. So one thing, so I guess the LLM didn't kind of put them together. I don't really need to save this. The LLM didn't loop these together, and I'm wondering maybe putting the quotes together might help it further. So I could try to do that. So quotes to support weakness one, input one dot, forget what the quotes are called, honestly. Quotes, duh, okay. And then I can do the same thing here for weakness two. Quotes to support weakness two. I'm not really going to change the blocking threshold, honestly. This is okay, because the blocking key itself is only weakness short name. Okay, so let me run this. Again, it's going to read the cache when I can. If I were to go here. Yep. And then hopefully it did rerun the last one. Yeah, it did. Okay, so if I were to look here, insufficient. Oops, make this bigger. I wonder where that baseline one. Oh no, comparative analysis is still different from failure to compare with recent baselines. Okay, maybe I have to put something in here that says, um, if quotes mention the same idea, these two weaknesses should be merged. Okay, try that again. Okay, it went recanonicalized. No, I have the same problem. Okay, maybe the blocking threshold is too high. I wonder. One thing, I guess I could try to lower this. I mean, I should use the optimizer to try the right blocking threshold, but I'm just gonna lower it in case. Um, Run it. Okay, so does look like, all right, here. Failure to compare with recent baselines and comparative analysis are not merged, but it seems like there are other things that are merged. Experimental validation, clarity and presentation issues. Okay. Limited data set variety, unclear practical implications. I do want both of these to be the same, and my honest thing is probably um these embeddings are just very different. So, I mean, in this case, it doesn't matter too much to me, but in the future, we're going to have the ability to be able to modify these clusters yourself, which will definitely be really helpful. Limited data set variety. I do think that also might be different. Or maybe it's an insufficient experimental. I don't know. This really highlights the subjective nature of all of this. Um, but regardless, I think this is okay. And I'm gonna move forward. Um, I'll save this. And then finally, for each one of these groups, I want to create a summary. So to do that, I will have a reduce operation, which is basically many to one. And I'm going to call this summarize weaknesses, summarize weakness. And the weakness key will be, I believe, weakness short name. sorry, the reduce key. So that means for every distinct value of the weakness, the canonicalized weakness shortening, I'm going to summarize all of the quotes for it. So you are determining weaknesses in AI paper reviews. Stated. Analyzing. Okay. For the weakness, use key. Here are many of the quotes from reviews that correspond to it. And then again, I have to do another for loop, which I never know how to do here. So instead, I'm going to do quotes and then input dot quotes, I believe. And then what do I really, I want a summarize why the submissions based on these quotes. Summarize why the submissions exhibited this weakness. Include quotes and yours. And I'm going to do this summary string. Okay. And let's run it. Okay. So here we're going. As usual, we read the cache. Now we are processing our reduce operation. Didn't cost anything. Yes, because now all of the bulk of the work is done in the map operation. Those are where the documents are really big. And now in this reduce, right, these quotes themselves are not so big. So here I can kind of see this is very similar view to the resolve. Honestly, just like a histogram of how many documents have each weakness. And here we have the summaries. Okay, so I can kind of see for lack of novelty and contribution. So as a CS reviewer for myself, I kind of understand what that means, but I'm curious what the ML community thinks are clarity and presentation errors. Okay. Writing quality, organization, and specificity of descriptions. Interesting. Organizational flaws. Rather, descriptions are vague. Consensus among reviewers that clear elaboration and correction of typos and formatting issues are necessary. Interesting. Insufficient experiment. That's interesting to me too. The experimental. Okay. It's comparative analysis we already kind of knew. Weak theoretical contribution. Interesting. So this is cool to read. And at this point, I mean, I could definitely do some more prompt engineering to try to get to what I want. But honestly, I feel happy enough to run this on my pipeline as is. Um, so with that being said, there are several, I could kind of do it in this interface myself if I wanted to. I could export this pipeline to the YAML file and I could run it in my terminal, which honestly might be better. I personally prefer that. So let me do that. Called review analysis.yaml. Or well, I guess those are the only two ways I could do it, either in the UI or in the YAML. So some things I kind of want to conclude with are it only really cost us $1.48, which is kind of crazy. We did this in a fairly short amount of time. We did it in about 30 minutes, and I talked aloud. I'm very bad at talking aloud while typing, so it probably would be faster if I weren't doing it in a video. And yeah, and save this here. So if I refresh it, I'll get, the same thing. won't really lose my progress. I'm excited about some features that we're working on. The ability to kind of edit summaries here in the output table would be great. The ability to add notes. So you can kind of already do that now. It's useful for like collaboration. Say I cared about this sentence a lot. I could add my own notes, or just not add anything, save it here. And we're also building an assistant to help people, especially, remember in the beginning, we had these instructions around, finding as many common weaknesses as possible. We didn't like ultra specific weaknesses that were specific to a submission. So we could kind of highlight examples of things we didn't like and maybe have an assistant edit the prompt for us to reflect that. So there's a lot of really exciting directions that we can go from here. Hopefully this UI is just, it's a first pass. Hopefully this tutorial gave you a good understanding of, what you can do with DocETL in the UI. We're also working on interactive optimization of the other operators, as well as the resolve operation that I showed you. And yeah, check it out. Let us know what you think.